Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy's DEVASC 200-901 Certification Exam Preparation course, and in this video we're going to be focusing again on Lab 1.3.3, talking about Python programming. And what you're going to learn in this video is we're going to be focusing in on Python lists and dictionaries, and we're also going to be picking up a few new built-in Python functions. So let's go ahead and transition over to the virtual machine. Again, as a reminder, you could do this with the Integrated Developer Learning Environment idle on your host operating system, so you don't need to use the virtual machine. However, the virtual machine is where I'm going to be doing all of my demonstrations. You can see we're going to pick up right where we left off here. And so let's focus in first on lists. So I can create a list using a variable name here, and I'll just say my list, and I can create an empty list. Now, again, duck typing with Python. As soon as I use those brackets right there, Python knows that I want to create a list, or that I have created a list, and we'll say my list. And let's check the type. And you can see right there that Python says, yes, this data type is a list. Now, how can I add things to my list? Well, I can create a list. We'll say my list 2, and maybe we want to have some things in here already. So I can put in the integers 1, 2, and 3. So if I was to try to print out my list 2, and again, we're in the interactive interpreter, so I don't need to say print my list 2, although this will work. In the interactive interpreter, you simply need to type in the name of the variable, and then it's going to print the value out. And you can see again that my list 2 is in fact a list, or an object of data type list. So we've got these two lists. One's empty, one has a few things in it. So how would we access the individual elements that might be in that list? Well, this is where it comes to indexing. And it's very important to note that Python is a zero-based counting language. So the element in the first index position is actually index position 0. The element in the list that's at the second position is at index position 1. So the counting starts at 0, and then the third and final element in the list is at index position 2 for this list right here. Now, there's also an interesting way that we can access these using negative numbers. If I wanted the last element in the list, I would use -1. And this becomes very handy because this guarantees that irrespective of the size of the list, if I index into that list with -1, I'm guaranteed to get the last element in that list. And this would be -2, and this would be -3. Again, with lists that have more or fewer elements, your numbers will definitely change. However, -1 will always be the last element in the list, and 0 is always the first element in the list. So let's clear the screen here, and let's take a look at what this looks like in practice. So how do I print up the elements of that list? Well, I can say my list 2, and we use the open bracket, and I'll do 0 because I want the element that is at the first index position, or the first element in the list, and that turns out to be the integer 1. Now, how can we confirm that that's an integer? Well, I can simply put this inside of the type built-in Python function, and it's going to tell me, hey, that's an integer. Now let's go back and let's do index position 1, which is the second element in the list, and that is the integer 2. If we did index position 2, this is the third element in the list and the final element. And if it's the final element in the list, I could say -1. And that's going to give me the last element in the list. -2 gives me the next to last. And then -1, in our case, is going to give us, excuse me, not -1, -3. Apologies there, is going to give us the first element in our list. Now, that will change as the list grows and shrinks. However, again, the two values that are very important to remember are 0 is the first element in the list, and it's an ordered list. And you should probably see that because we're accessing the elements in that list with 0, 1, 2, 3, 4. So a list is an ordered collection of different Python object types. Now, the cool thing about lists is that we can actually add things into a list using a method. So if I was to say my list, whoops, and put a period and then hit the tab key twice, you can see that we have a number of methods here. Remember, a method looks like a function, except it's inextricably linked, related to the data type we're working with. And so in this case, we look at the append method, and that is inextricably linked to lists because we can append things to lists. If we were to look at a string, chances are we wouldn't see append, or an integer, we're not going to see append. However, here we can append an element, or I should say an object, to the end of the list. That's what append means. So let's go ahead and let's append a string. So we'll put the string hello in here because lists are extremely flexible. They can actually contain all the other Python object type or data types. So I could put a dictionary into a list. I could put a string, an integer, a float. In fact, I can put another list inside of a list, which is something that we're going to do. So now let me go ahead and say my list, and you can see we have the string hello. What if I wanted to append a float like 3.1415? I can do that. I can append an integer, 99. And now when we take a look at my list, you can see that the list contains 3 elements, and the limit to the number of elements that you can put into the list with Python 3 is really bound by the amount of memory that you have on the system you're working on, right? So there really is no set limit. Your system's memory is going to be dictating that. So we can add in something else. Let's go ahead and let's add in another list and see what that looks like. And I'll put 7, 8, 9. And so we've just appended a list into our existing list with the name my list. So what if I said my list -1? That's going to give me the last element in my list, which happens to be this other list, which is just 7, 8, 9. Now let me append something else here. Instead of a list, let's append a tuple. And so I'm going to put in here 1, 2, 3. Oops, I'll just do 1, 2. There we go. And when we say my list, you can see we have this tuple at the end. And so if I say my list -1, we get the last element in the list. So if you're ever asked to get the last element, you don't have to go, okay, 0, 1, 2, 3. Okay, so it would be 4. And then you hard code into your program, all right, the last element is 4. And if that list changes, either reduces in size or increases in size, that last element index position is going to change. It might not be 4 any longer. So that's how you can append items into the list. We could also go ahead and make copies of a list. There's nothing that says that I can't say new list is going to be assigned the value of my list. And so now if I say new list, you can see new list has the same elements and the same number of elements as my list. And so that's a very easy way that we can create a list that has similar values. All right, so now what if I wasn't sure? Now, looking at the screen here, it's easy to say, okay, well, that list has 1, 2, 3, 4, 5 elements in it, right? We can easily count that. There's an easier way to do that, and that's to use the len, or short for length, built-in Python function, which, when given a list as the argument to the function, will tell you how many elements are in that list. And so let's go ahead and we'll pop back over here and let's append something else in here. We'll just throw a number. We'll say 8675309. And then let's rerun that length command, and you can see that it picked up that, hey, there is a new element that has been added to the list. In fact, if I say my list -1, what should we see? Yeah, we should see the last element in my list, which is now this new integer, 8675309. All right. So we've looked at how we can check with type to see what type my list is. And you'll notice that it's a list. We've looked at len, so we can see that. Now let's go ahead and talk about this from a networking perspective, right? Well, maybe we want to use some devices. We want a list of devices that exist on our network by name. So I'll say router 1, maybe it's switch 2. We'll put in here router 99, and then maybe we put in here AP 3602, which is an older AP model, and maybe it's the third one that we have on our floor, right? And so now I've created a list. Let's think of this as maybe an inventory. And the list name is devices. So when I type in devices, Python's going to tell me, hey, here are the 4 the 4 elements in this list that make up this list, which are, for all intents and purposes, are networking devices that we have somewhere in our building. And again, you can access these just like you would any of the other elements in the other lists that we've looked at. So if I say devices -1, again, I keep hammering that. Very important is that is always going to give you the last element in the list. So we've got some devices listed in there, and that works really well. And so we're going to talk a little bit now about slicing. And so what I'm going to do here is I'm going to say devices append, and let's append in here router 100, and we've got what? We've got 5 elements in our list right now, so that'll be enough to work with here. So what if we wanted to display, we can say devices, right? And that's going to print everything out. But what we can also do is we can do what's called slicing, right? If I just want a slice of that list, and here's what that looks like. I would use some integer here, and I'll use 1. And so this is going to give me from the element at index position 1 up to the element, but not including the element at index position 3. And so what that means is I'm going to get index position 1 and 2. So I should see switch 2 and router 99. Again, remember, it's inclusive, exclusive is how I like to think about it. So it's going to include the element at that index position 1, and go all the way up to, but not include, the element at index position 3. Now, let me ask you this. What do you think this might do if I was to say devices, and I would, I'm going to do the bracket there, and I omit the leading integer, and I just simply say :3. What is it going to assume is the default there? And from looking at this, we can see that it assumes that I'm asking for everything from index position 0 up to, but not including, index position 3. In other words, what we're seeing here is, translating that to English, it's give me all of the elements in the list, starting with the first element, all the way to, but not including, the third, the element at the index position 3. So we get index position 0, index position 1, and index position 2. Again, if I run that again and we put in here 4, we're going to get index position, the elements at index position 1, 2, and 3, right? Or sorry, 0, 1, 2, and 3. Again, because we omitted the leading integer value of 0, 1, whatever we were going to use. So we get from index position 0 up to index position 3. And that's what we refer to as slicing. Now, slicing is definitely pretty cool. And I'll show you, I don't want to call this a trick, but if I was to say devices and then omit the leading integer and the ending integer, just have a colon in there, it's simply going to print the list for me. However, it's not very realistic because I can just simply say devices and I'm going to get the same thing instead of having to, reach up, possibly typo the open bracket, and then the colon and then the closing bracket. However, there are some uses for this when it comes to making copies of things that you may want to employ. However, we'll get to that a little bit later on when we talk about deep copies and shallow copies. All right, so that is sort of lists in a nutshell. And I've given you some ideas on how you can access the elements of the list, how you can do some slicing to get maybe ranges of elements in that list, and how you can always access the final element in the list. So now let's move on to dictionaries. And dictionaries, unlike lists, dictionaries are unordered. Now, I say that with an asterisk because in recent Python distributions or recent Python versions, there is some internal ordering that's taking place, but we don't see it. Just imagine it as the magic behind the curtain. So again, it's a general statement to say that it's unordered because when we access things, we're not using index positions with dictionaries. We're using key value pairs, and specifically we're using keys to access the elements of a dictionary. But know that technically behind the scenes that there is some internal ordering that is taking place. So enough about that. Let's go ahead and take a look at some dictionaries, right? So I'm going to go ahead and create a dictionary, excuse me, and I'm going to call this dictionary device. Well, actually, we'll call it routers, right? So I already used devices. So many times you're going to start your programs. You'll have in your programs early on the creation of either an empty dictionary or an empty list, because at some point you're going to start to populate that list or that dictionary. This is how you would create an empty dictionary. And we use the braces, the curly braces here. So if I say type routers, this is going to come back and tell me that, hey, routers is a dictionary. But this is where dictionaries can become a little confusing for learners, because to add something to a dictionary, we're going to go ahead and do this. Now, this would be the key here. Now, the keys, and I'm going to use a turn of phrase here, the key to the keys, right? But not to be confusing. So the rules around the values that can be keys is they need to be immutable data types. Now, we haven't talked about mutability and immutability. We'll be doing that shortly. But just know that mutable means that the values can change, right? And the mutable data types would be a list or a dictionary. Immutable means that the values cannot change, and specifically they cannot change in place. And again, I'll get into the semantics behind that because it's important. However, just know that the immutable data types that we would be looking at for our dictionaries would either be an integer or a string. Those are going to be the most popular. Now, all the immutable data types are valid keys. However, we're going to focus in on integers and strings. And so you can see here, if I used a string, we can call this key1. And this is one way that I can add key value pairs into 10.1.1.10, right? So we'll just say key1 and we'll throw an IP address at it. And so that is how I can add a key value pair to my dictionary. Now, the reason that learners become a little bit confused here is this syntax, is they see the open bracket, close bracket, right? And this kind of triggers that memory of, hey, wait, you said this was used with lists. And that is correct. It is used with lists, but it's also used with dictionaries when we're adding a key value pair here. And again, if I was to rerun that command, let's put a different key in here. I could say key 2, come back here and put 11. And so now we have a dictionary that has 2 key value pairs. Now, I don't know the technical reason as to why we don't use the curly braces there, right? Or why we don't use the curly braces here. Now, again, the dictionary is unordered in the sense that the way that we access the values, the key value pairs, is not based on some order like 0, 1, 2, 3, like a list. We access the values out of the dictionary based on the keys that are in the dictionary. So if I wanted to see what key number 2 held in terms of a value, I would say routers, and then again, we use the brackets, not the curly braces here, in order to assign values by key value pair, and in order to get the value using the key. And this is important because when you're learning dictionaries, you're so focused on the curly braces that this might become a little confusing, and you may say, oh, well, wait, I do this with a list. Well, no, we also do it here with a dictionary. Again, I'm not sure why they didn't use the curly braces there, but they just don't, right? And so that's really a dictionary. The key, right, is in the brackets, and then the value is assigned to that key, so to speak, and then it all gets assigned to the dictionary. And that's how we access the values that are in the dictionary. Now, you may be wondering, hey, so you're showing that up here we're adding a single value in. What if you know, key 1 had a couple IP addresses? What would that look like? Well, let's go ahead and do that. Let's say routers, and we're going to use key 3 here. Again, I'm just going to use a new key value, and then let's use something else here for multiple IP addresses. Well, could I assign this a list, right, or an integer? So if I do that and we go back and look at routers, you can see, sure, I can have a key and then the value of that key could be an integer. If I was to pull that back up, what about a list? What if I wanted to put in here 192.168.1.10, and we're going to put a list. We'll put 3 elements in this list, and whoops, let's remember our double quotes. 192.168.1.11. And can I mix and match here? Can I do double quotes for some things and single quotes for others? Let's take a look at that. 168.1.12. And that, that is what I'm going to add into my list. And you can see I can mix and match there. Would you do that? Probably not. But again, it's a question that comes up sometimes. So here is my key value pair for key 3. And the value is a list that has these 3 elements in that list, which are all 192 IP addresses. So now let's talk about, you know, okay, well, great. So what if I wanted to retrieve, and I think we had it there, what if I wanted to retrieve key 3, right? So there we go. And here I can confirm for you, if we were to do this and combine these commands here and say, hey, give me what's at key 3, and I want to know what data type is that. And there it is. It's a list, right? Now, what if I wanted to drill down a little further? So I get the list, but I want the last element in this list. How would I do that? If I want to print out only the 192.168.1.12, that would be easy. That gives me the list. -1 is going to give me the last element in that list. In fact, if I was to go ahead and check and say, tell me, Python, what data type is that last element in the list that is associated with the key 3? And it's going to come back and tell me it's a string. And we know it's a string. It's because it's inside the single quotes, right? So that's how we can kind of poke around in there. If I said, give me the first element out of that list, I could say 0. I'm sorry, it's a string. And we were looking for this right here. Apologize there. And that's the first element in the list that the dictionary key 3, has as its value, right? So pretty handy. And you could even put a dictionary inside of the dictionary, right? So I could do the following, and maybe, I think I may be going back, have to go back too far here. Hope not. Okay, there we go. And so let's do this. So again, I'm going to say key 4, right? This is going to be our new key. And I'm going to assign this a dictionary, right? So what are we going to use? I'm going to use 1 for the key, and for the value, I'm going to put in here router 1, right? Something, oops, keep forgetting to get shift down there. And so that is now a key value pair. So how would we access that? I say routers, and again, I could do a single quote here and say key 4. And there we go. So now the question becomes, okay, well, what if I want the value that the key integer 1 in that list right, or in this dictionary right here, I want to see this value and only that value. Well, okay, so I say routers key 4, and that gives me the dictionary. And so what if I do 1? And there it is, because that was the key, right? 1, the integer 1, is the key in that dictionary. And so this is how you can access the different key value pairs that are inside of the dictionary. Now, it's also important to note that you can use the built-in functions, right? So there is a dictionary function, and there is also the same function for the list, right? And you can see, I say list, it gives me an empty list. If I said dictionary, right, it's going to give me the empty dictionary. And so we'll probably stumble upon these a little bit later on, but this should be enough to get you going. And that is going to conclude this video tutorial where we took a look at part 4 in lab 133, and we focused on lists and dictionaries. And we saw the length function, or len, stands for length, that tells us how many elements are in our list. And the question, let me take a step back here. The question does come up, well, would that work with my dictionaries, right? And how many key value pairs are in routers? And they're separated by commas, so you can see we've got 1, we've got 2, we've got 3, and this comes way all the way down here, and then we've got 4. So len also works with dictionaries. All right, thanks so much for watching. I hope you're enjoying the course so far. In our next video tutorial, we're going to be taking a look at the input function, and we're going to be kind of messing around a little bit with what happens when the user puts an integer in, or when we want the user to enter an integer in, and what the default data type is that the input function is going to return to us. All right, as always, whoops, I apologize there. As always, thanks so much for watching, and I hope to see you in the next video.